follow this talk using that as well. We'll probably not go through all the slides. We'll just skip through some bits and focus on some of them as that we think are important. So if you're on this call, I suspect you're a software developer, or you're a project manager, or you're in one way or the other, you work in building software. And this is not going to be any kind of breaking edge talk. This is more just revisiting the fundamentals of what agile software development is and isn't, and kind of what it tries to achieve and where it comes from. If you have any questions, please use the questions app or the chat feature to just send a question, and I hope I can I'll try and answer that for you. So yeah, we're gonna start with that. We'll start from probably we'll look at the Agile Manifesto. The Agile Manifesto, I think that was written sometime it's quite a while ago now, and it basically says that we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we've come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. I'm reading this from the page 8 of the slides, if you have access to that. The manifesto says that is, while there is value in the items on the right, we value the items on the left more. And it's important you understand where this manifesto was coming from. This manifesto was written by a bunch of software experts, software luminaries, who had struggled with what we would describe as the waterfall software development process. The idea that you could write software with a bunch of upfront specifications. You'd have to specify upfront and in detail all the requirements of the software, and that you would once you can accurately specify all that's needed to specify all the requirements for the software, that then someone can go and develop it, write out the software over a period of weeks or months and come back to you with the finished product. So in that world, in this kind of waterfall front world, you have things like big design up front. There was a lot of time spent doing analysis, a lot of time spent gathering the requirements. These things were done in a staged process, and a lot of time spent doing design, a lot of time spent doing implementation. And at the end, there was a stage for testing the software to make sure it met the requirements. But this Agile Manifesto and this whole kind of Agile movement came up to challenge that, because the proponents of Agile felt that the kind of waterfall approach had quite a few constraints, had a few limitations that were not working for the business challenges and the software projects that were needed at the time. And so this Agile Manifesto, if you like, specifies the values, what was important. A few people who came to write this manifesto, like Alistair Copon and Martin Fowler, and the people who lean software development, Mary Poppendike, and a few others, they all had different methodologies, but they felt that these values encompassed all the different methodologies, whether it was Scrum, whether it was extreme programming, whether it was lean software development. These values were shared by all those different software methodologies. And just before we go on, I really want to highlight. In fact, we're going to spend a few of the slides just highlighting what's really important and why these values are so important. It's important to note, agile software development is not a silver bullet. It's not going to solve, all our problems, but it's really important to understand why why it's needed. The focus of agile development is really about individuals, and it's about people. And this is coming from a time when processes and tools were, if you like, considered to be more important than individuals and interactions and the communication that happened within individuals. This was coming from a time when you had what you call heavyweight processes and different kinds of modeling tools and design languages and all kinds of things where, I guess, were considered more important, or the process was considered more important than the people and interactions involved. And the kind of agile software development idea was meant to, if you like, influence the values towards individuals and towards the interactions that happened among between them. And so there's a preference for highly skilled people who interact well, who work well together. There's also the other thing that on page 16, if I'll just flip down to that, the other thing that's also quite important about agile software development is that there's an emphasis on working software over comprehensive documentation. More time, I guess, is given to actually developing software and showing it working than perhaps spending a lot of time trying to specify what that software should do in large requirements documentations. If you look at verse 18, one of the problems of, I guess, the waterfall process, which the agile process is meant to challenge, is that a lot of time is spent trying to produce documentation, requirements documentation, trying to keep them in sync, trying to keep them meaningful. And agile is meant to actually, for most projects, demonstrate value or spend most of the time on the project on actually creating software rather than writing documentation. There's an emphasis on page 22 of your slides. You can see there's an emphasis on customer collaboration over contract negotiation. So most agile methods we would look at would somehow involve more or closer discussions with the customer, in negotiation on the scope of the work to be done. There's more of collaborative problem solving rather than a typical waterfall approach or waterfall project where the customer specifies what needs to be done upfront, goes away and kind of throws the requirements at the development team. And 1 year later, the development team is supposed to have the sparkling, brand new working software that kind of magically meets all the requirements. The agile focus is a bit different from that. On 24, on slide 24. You see that focus on it's about responding to change over following a plan, and this is quite important. A lot of the methodologies would look at in further meetups we're going to have. Will be about how we can respond to change. Respond to the business need rather than following a plan. It's quite important to understand that businesses have uncertainty. Most of the time we're writing software on projects where it's not entirely certain, even the business is not entirely certain if the software will drive the revenue they want, will drive the profits they want. The business wants a way to explore, to experiment what will work and what will not work. The business is more interested in not just in the software, but in the solution, in driving revenue, in solving a business problem. And so what some businesses want is a responsive software development process that responds to change, that adapts to, new information as it arrives. And so agile processes are really focused on responding to change rather than some sort of initial plan of how things are expected to turn out, because we all know they won't end up turning out that way. So if we just go to page 27, we'll start looking at the principles of the Agile Software Manifesto. And this is where I want, I guess, to spend most of the time. Principles of the Agile Manifesto. And I think this is really the really interesting part for me. There are 12 principles, and you can find this on the Agile Manifesto website. You can just Google for Agile Manifesto, and you'll see the website there. One of the number one principle is that our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And that's quite a loaded, it's quite a big statement to make. That the number one priority is to satisfy the customer with early and continuous delivery of valuable software. So the focus is to get the software out there early, to get feedback based off that software, to have to demonstrate to the customer working software as early as possible, and to develop the features that are of highest value to the customer first. Now, the whole idea around this is, rapid iteration. It's gaining customer confidence, is testing assumptions and fleshing out, assumptions that are true and that are not true. It's about building a reliable process of delivering the software and removing uncertainties as they crop up. The second principle is welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. And this is where what I talked about earlier, harnessing change for the customer's competitive advantage is quite important. In our next upcoming meetup, we'll be looking at extreme programming, and we'd look at how that focuses a lot about building software in an environment of uncertainty. Again, as I talk, please feel free to chat any questions you have in the group chat. Let me know any questions you have, and I'll be happy to answer those. So it's about welcoming changing requirements late in the development, in the development processes, because agile processes work in really short batches, really short iterations, really short development cycles. It's perfectly okay for new requirements to come up during the process, and the new requirements will just be incorporated into the next development cycle and will be worked on. This is quite different from, if you like, the waterfall approach, where bringing new requirements after the contract has been negotiated and the entire scope of the project has been signed off is a big is the big change, because it affects all kind of things. It affects the price of the contract. It affects where things have been rigidly signed off. That the waterfall process is not very flexible to that kind of change of new requirements coming up. The other thing is delivering software deliver working software frequently from a couple of weeks to a couple of months, with a preference to the shorter time scale. I really like this one because a few studies have shown that companies that deliver software frequently tend to have higher quality software. Again, I mean, today when this, if you like, Agile Manifesto first was came out in the early 2000s, this idea was seen as in some respects revolutionary. But today we see many companies deploy software to production several times in a day. They built deployment pipelines to enable them deploy software to production, working software to production several times a day. And again, this ties into the value of getting feedback, of getting quick feedback, short development cycles that embrace change. It's not about a fixed scope, contract scope. It's about working close collaboration with the customer, working on the customer's next most important, change or new requirements, collaborating with the customer to actually solve a business problem rather than just delivering software at the end of a project. So it's about building a pipeline to allow as frequent delivery of software as possible. Now that software can be put in production or can just be put in some sort of test environment, and the customer can determine when it will be put in production. But the key thing is to deliver the software frequently. On page 33, I've put a slide there with links to a tracer, a short video on YouTube about using tracer bullets in combat. So this is tracer bullets are used by soldiers in combat to light up the the night when they're fighting in the dark of the night and can't see very well to shoot at their target. They fire tracer bullets that light the way and help them aim better at their targets. And this is quite important because the soldiers, in the night, you can imagine trying to shoot a gun or aim at a target in the night. There's lots of uncertainty about in trying to hit the target. Trying to hit a target you may not be able to see because it's dark. But a tracer bullet, which lights up the path it takes, shows exactly where the bullet will land and illuminates the path. And if the target is along that path or near that path, you could see it. And then you can correct. You can correct based on the feedback from that projectile, and you can aim better and then fire. So there's this phrase by Andy Hunt and Dave Thomas in the book The Pragmatic Programmer. It's ready, fire, aim. So it's kind of fire first and then use the feedback and information you get from that to better your aim, so that you can fire better. And this principle is very important when there's uncertainty. You can imagine on most large scale projects, the larger the project is, the more uncertainty there is. And uncertainty can come from, all kinds of places. On slide 34, I talk about all the different places we can see uncertainty. We can see a change on any large software project, any large enterprise project. There can be new technologies involved, new libraries, new servers, new tools, new developers, new requirements coming up, new teams, new techniques. There's so much uncertainty that sometimes it's difficult to specify in detail everything. I mean, just looking at the requirements, it can be difficult to specify all the requirements upfront for 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 a large project, because there's so much there can be so much uncertainty in involved. First of all, the business may not know exactly what they want. They may not know the details and specifics of everything that they want. And there can be lots of uncertainty on that. The requirements can be vague. The development team might not be 100% sure of their architecture. If it's a new architecture, they're using some sort of new framework. Again, there's some sort of uncertainty in that. And so trying to nail down and trying to specify all the requirements upfront can be, a difficult task. And so the principle of delivering the software frequently, seeing if it works, can help flesh out uncertainty, can help clear up assumptions. The customer can actually try the software and we can actually prove whether our assumptions are correct, whether it's working the way we expect it to work. I think this is a very important principle I find among really mature development teams. They're able to deploy, get something out very quickly and iterate on that, rather than, say their first deployment is going to be 6 months away, and then it's really sometimes difficult to incorporate feedback from what you've learned from your release when you've already built up a lot of software. Anyway, let's go on and look at the other principle. Is that business people and developers have to work, and I'm looking at slide 37 for this. Business people and developers work together daily throughout the project. Again, business people and developers work together daily throughout the project. Agility requires significant and frequent daily interaction between customers, developers, analysts, and testers. Some agile processes like extreme programming would go as far as saying it would be great to have an on-site customer, someone who can work with a team and specify the requirements, can be there to answer questions about the requirements, and someone who has domain knowledge, who knows a lot about the business, knows what's important and what's not. This principle comes from the value of close collaboration with the customer daily. Again, the focus is on solving the customer's highest problem or most valuable, delivering the most valuable features and the highest priority features before, I suppose, less important and less urgent ones. Another principle is to build, on slide 39, to build projects around motivated individuals, giving them the environment and support they need, and trust them to get the job done. If you remember when we talked about the values, we talked about individuals and interactions over processes and tools. Agile software development requires, motivated individuals. It requires trust. It requires trusting the team. It requires allowing the team to make the decisions, because the team building the software are the ones who probably know most about the technical challenges involved, and should probably be the ones taking decisions on some of the technical, or at least making some of the technical decisions on the project. It's about trust. It's about allowing those people who know most about a problem to solve the problem and to make decisions on how to solve that problem. It's about, because it's about the people and not, it values the people more than the process. Agile processes would prefer or would lean towards changing processes to help the team, changing processes to make the team work better, changing environments or tools. If a tool is not working for a team, change it and get them something that they think would make them more efficient, more performant. Sometimes it can come down to changing even the office environment, and making it more collaborative. I remember working for a client in financial services industry, in and it was a bank, and sometimes they would try to stick you know stick up a storyboard with user stories that we were working on, and I think we did that on the wall, but the facilities team in the large building were not really happy. They were not enthusiastic about us sticking stickies and cards with plasticine on the beautiful windows of the office, and so we had to get that removed. So I suppose Agile doesn't work very well in those kind of environments. Agile works in a place where you enable the development team by giving them all the resources they need, the space they need, whiteboards, um, the tools they need, whatever they need to actually, and trust them to actually get the work done. Um, another principle we Another principle of agile software development on slide 42 is that the most efficient and effective method of conveying information to and within a development team is face-to-face conversation. And I really like this one because I like the idea of tight communication within a software development team. Face-to-face conversation is the primary mode of communication in most agile teams. Agile methods believe that the most efficient and effective method of conveying information is not written documentation, even though that has its place, is not necessarily phone conversations, even though those have their place, is not instant message, even though that has its place. It's about face-to-face, or the development team possibly in one place, if that's possible, and having face-to-face conversations, talking to each other about what needs to be done. It's amazing how much waste and how many errors crop up in software development from just poor communication. When there's poor communication, it causes all sorts of issues. On any typical software development project, if a developer is working on a problem, there's a great chance that another developer on the team might have ideas. If one developer is stuck, perhaps there's someone on the team who has encountered a problem before and has a solution. And simple communication would just resolve that problem. And so agile methods try to enhance communication in the team. They do this via various ways, planning meetings, scrums or stand-ups, pair programming, demos, end of sprint demos. All these things are meant to enhance communication within the team. Again, this is coming against a backdrop of waterfall development, where the primary method of communication sometimes is just huge requirement documents or huge modeling diagrams that not everyone, which may be difficult to understand, no matter how hard you try to write down these requirements or draw UML diagrams, large design diagrams, which have their place and can be very good, but sometimes it's difficult to read and understand, and miscommunication is so easy to happen. And not to mention the fact that it's also a source of waste. Sometimes you spend a lot of time writing down requirements and creating design documents that end up not being used, because the requirements have changed, and you just have to throw all that work away. To and so to eliminate waste, uh, face-to-face communication is preferred for, perhaps not all. There's still some things you need to write down. There's some things you need to put on a wiki, on sort of some team information repository. There's still some things that you need to track in your project tracking tools, Jira or whatever. But face-to-face communication is still great for many kinds of communication on the project. The next principle is that working software is the primary measure of progress. Working software is the primary measure of progress. This is, this is saying that Gantt charts with milestones are not the primary measure of progress. Showing up some PowerPoint slide saying what has been done and what's left to do is not the primary measure of progress. Actually demonstrating the software, showing working software, is the way to gauge exactly what has been done. And so the most agile methods, or the agile processes would encourage having frequent demos or customer demos at the end of every sprint, or as often as possible, deploy to a production-like environment where possible, and showing what has been done and is working to the customer, gives the customer that sense of confidence, and they can see for themselves what has been and what has not been done. It's honest. It's an honest way. It's an honest demonstration of what's happening. There's a popular or well-told developer joke that goes something like, it works on my machine. And we know many times that it works on the developer's machine doesn't necessarily mean that it will work on the test environment, or that it would work on production. There's configuration to be done. You have to make sure all the necessary files are checked into version control, and all the all the settings and environment variables and everything's are set up correctly. So showing working software, demonstrating working software is the primary measure of progress. Again, as I continue, I'd please ask if you have any questions. Please feel free to chat them on the Q&A or on the chat box. The next principle is that Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. So the idea here is to avoid burnouts. The idea is to work at a constant rate, for long periods. This, again, against the backdrop of waterfall projects, where the projects, in a waterfall project, when you've gone through the requirement stage and the design stage and the implementation stage, and it's now down to the testing stage, or somewhere about that, and you're way down, a lot of time has already been spent. Now, if we find out bugs late in this development process, you can imagine there's lots of late nights involved, lots of late nights and overtime in trying to fix issues. And that kind of unsustainable push or death march, as it's called, sometimes um, is really not favored by agile processes. Agile processes look for a sustainable pace, constant rate of delivery, that that it's almost predictable. You can predict based on the you can calculate the velocity of the team, how frequently they deliver um, functionality, and you can use that to predict how much work would be done by when. Um, it's a feature of most agile processes. I like this quote by Tom DeMarco on slide 47. It says, "Overtime is like sprinting. It makes some sense for the last 100 yards of the marathon, for those with any energy left. But if you start sprinting in the first mile, you're just wasting time." So yeah, sometimes it's what putting in that extra time and that extra effort to push software out the door, to hit a deadline or to just complete the features for that sprint. But it's not, having overtime and working over long hours every time. It's just not sustainable. The next principle on slide 49 is that continuous attention to technical excellence and good design enhances agility. And what I find is most people, when they talk about agile, they seem to miss this one. There's I guess less focus on the idea of continuous attention to technical excellence and good design. One of the books I really love is a book by Robert Martin called Agile Software Development, and it takes time to discuss software design principles, the solid principles, single responsibility principle, the Liskov substitution principles, and so on. Those good design is so important to maintain and enhance agility. The idea of agile software is that the software is flexible. It can be changed in future when new requirements come up. You don't need to throw the software away and start afresh. You can modify it. You can modify it. You can improve it. You can make it better. It's about good design principles. It's about all the things to promote technical excellence. Using good version control tools, using a great software delivery pipeline, maintaining clean code, maintaining good automated tests, unit tests, test-driven development, code that's easy to read, adding code comments where necessary or where useful, software that it's easy to deploy, software that has good monitoring tools, that's easy to build and test. All these things, this continuous attention to technical excellence really enhances agility, makes it easy to change software quickly to meet new requirements. The other principle of agile software development is simplicity. And simplicity, I like this one, is the art of maximizing the amount of work not done. Simplicity is essential. Simplicity is one of those things that's easy to say, but it's sometimes hard to do. So simplicity, it's in software development, many things we find are they're simple, but they're not easy. So simplicity doesn't mean that it's easy. Sometimes simplicity is actually hard to do. And I really like this description of simplicity, the amount, maximizing the amount of work you don't need to do. It's about preferring simple solutions where possible, preferring simple solutions over complex ones. It's about minimalism. It's about not trying to build for tomorrow, rather building for today. It's about making the software easy to change. And this is so important because simple solutions are cheaper than complex solutions. Many times we try to build complex solutions and add add more functionality to a solution because we think we will need it in future. And so we keep building in features that we think we'll need in future. But most times we end up not needing those solutions in future. We're not sure if we will need those solutions in future. We may not need them in future. And well, when we build in features today that we're not sure we'll need tomorrow, what we're doing is we're paying upfront for something we're not sure we will need. And that comes with an extra burden of communication. You need to communicate what those features are. And now we need to take those features that we're not sure we need into consideration when adding other features that we think we will need. It just makes the code bigger and more complex to deal with. And so simplicity, going for the simplest solution, whether it's just one favorite example I have is sometimes you don't need a full-blown relational database. You could just write your data to a flat file if the software you're writing is that simple. Things like this, they're so important because they give you the option of developing a more complex solution in future if you need to, rather than having to strip out or make a complex solution simple. You could just it's better to go from simple to complex, at least in most cases. Going to the next principle. The next principle says that the best architectures, requirements, and designs emerge from self-organizing teams. The best architectures, requirements, and designs emerge from self-organizing teams. Agile methods require the teams to, take initiative, be self-organizing, and people. I remember working on one team. There's this idea of the code base belongs to. It's the team code base. It's not it's not any individuals. Individuals don't own parts of the code base, but the team as a whole shares the code base, and that the teams can self-organize. People can raise suggestions. People can learn from what's working, and people take the initiative, I guess. So it's about self-organizing and self-motivated people. Again, there's a sense of, on slide 55, I talk about the idea of collective ownership. All team members own all aspects of the project and can contribute to any aspect of it. No one person kind of, owns perhaps, owns parts of it. The other principle is that at regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. The team reflects on how to become more effective and then adjusts its behavior. The principle, the idea of frequent cycles, of short development cycles, is not just about the software itself, it's also about the team. It's about the team getting feedback on how it's working, adjusting, looking at what are the constraints to the team, what are the difficulties and challenges the team is facing, and what can the team do about that. It's about continuous improvement. It's about retrospectives, having a time set aside to look at how the team can improve how they work, and working on that feedback and becoming, more efficient, becoming better. As we head towards the end, I think that was the last principle. We've gone through the 12 principles. We'll just, as we head towards the end, we'll just touch on different kinds of agile methodologies. All these methods that we're about to look at, they all share the same values, and principles, which we've gone through. These are just, if you like, different implementations of these ideas. Different implementations of these ideas, and we'll just have a quick scan or overview of them all. The 6 that I've listed here are Scrum, feature-driven development, Lean and Kanban, extreme programming, dynamic systems development, and Crystal. Of these 6 methods, I suppose the ones that are more popular these days are Scrum, Lean, and Kanban, extreme programming. Those are probably what you would find among most development teams these days, or at least the ones I've worked on. Scrum was developed by Ken Schwaber, Mike Beadle, and Jeff Sutherland. It has some characteristics about Scrum. Is that Scrum has this idea of sprints and a backlog, a product backlog. There's a product owner, and there's also a Scrum Master who if you like, shepherds the team, raises a backlog of work to be done, and monitors the sprint. And a sprint is just a development cycle. It could be a week, 2 weeks, or so. And the team goes through working through this backlog of work, and working in these short sprints to develop the features, develop the software features for the software. We're going to be digging more into Scrum later on. There's also feature-driven development. Again, this is not so popular these days. One thing I like about this method is that there's quite a lot of focus on domain object modeling, and this is the idea that some time is set apart to actually do some design upfront for at least a part of the software, to model the software, design the software, model the objects involved, and do some design before actual development starts. Anyway, you can see on page 60 some other features of feature-driven development. The other method is Lean and Kanban software development. Lean, the idea of Lean software development was, I guess a major proponent of that is Mary and Tom Poppendick. Lots of the ideas here come from the Lean principles and practices from Toyota, the Toyota car manufacturing, Toyota manufacturing. And the idea, one of the ideas here is waste elimination, looking at areas that generate waste, looking at the value stream, trying to understand where the most value is added in the software development process. It's about finding out if there are any constraints. What are the constraints on that software development process? and working to improve those constraints. It's about options thinking and waiting for the least responsible moment to make design decisions. In other words, keeping your options open. I think Mary and Tom have a book called Lean Software Development, one of the classic books you could read about that. And also there's this very complementary idea of Kanban, which is about continual delivery and enhanced flow. Kanban is focused on the whole. It's about optimizing the whole process, not just part of the process. It's looking at the whole software development process. In fact, stretching it out, looking at the whole pipeline, the whole product pipeline, and rather than having, say, set sprints, actually creating a pool, some sort of pool that as things are delivered, more things come into play. There is an idea of limiting work in progress. There's a fixed amount of work that can be put into play in any given stage of the process, and when a stage is full, you can add more work, and if there's and then more resources have to be put on that stage to move work or stories down into further stages. So Kanban and Lean are quite complementary, I suppose, ideas, and we'll be talking of that later. Finally, well, not finally, the other methodology we'll look at is extreme programming. Extreme programming was created by Kent Beck. It works well for small and medium scale teams, especially in kind of enterprise software development environments. By enterprise software development environment, I mean working, large companies, software development teams for large companies that work on software, used for the company, or I guess for the customers. It involves rapid feedback, or it values rapid feedback, and it's tuned towards fast feedback. So really short development cycles to gain feedback, whether it's the development cycle as a whole or whether it's about the software. It's all about getting feedback, learning as quickly as possible. Extreme programming is very good for environments where there's high uncertainty. And that's where the feedback comes in as very useful to learn things you don't know or things that might not be true about the software development, about the project. Involves things like pair programming, which is one of the practices of extreme programming, where two programmers work on one computer and develop the software. This is all about, again, about communication, about thinking, about it's also about training, about learning, and about making sure that everybody knows about the whole code base. You could lose a programmer and the project will still go on because they probably paired with other people on everything they've done. So everyone knows everything about the project in some respects. Some of the practices of extreme programming are things like refactoring. Refactoring means changing the implementation of software without actually changing what it does, or rewriting software to make it better without changing what it does, what its inputs and outputs are, its interface, I suppose. And extreme programming focuses on this, or values this a lot, because it has this idea of continuous design, and that it's about doing bits of design or evolutionary design, and so refactoring is needed to evolve that design. It places a lot of focus on simple design and, again, automated testing. For example, test-driven development is an important idea in extreme programming. The other software development methodology, I think the second to last one we'll look at, is Crystal. which is about frequent delivery and reflective improvement. I think communication by co-located team members. It's about removing bureaucracy and distractions from the team, and helping the team reflect and improve on their, giving them room and scope to reflect and improve on their processes. And then we'll end with dynamic systems development. The one thing you have the slide, you can see that on page 64. The one thing I'll highlight here is the idea of the Moscow prioritization, that in terms of the task or user stories to be worked on, there's this idea that stories are prioritized by their must-haves, their should-haves, could-haves, and who, if you like, wouldn't get, but like. And it's a way of prioritizing stories to highlight which are most important to get done first. The ones that absolutely are essential are the must-haves. The should-haves come next. The could-haves, are ones that they're good to have, but you could drop it, though, if you were pushed for time. And then the wouldn't get, but like. These are ones that, the cherry on the cake, the ones you could aim for to delight the customer, but are not absolutely necessary. That's one thing to mention on this method. You could see the other ideas of like time boxing. It's quite a big feature here, where you have a fixed budget and a delivery date, but the scope is varied with the kind of Moscow prioritization we talked about. It also places emphasis on prototyping and testing during the iteration, stakeholder requirements workshops to map out exactly what the priorities are. I'm going to end by giving a bunch of references for further reading. 3 books I recommend are Agile Software Development Principles, Patterns, and Practices by Robert Martin, which I mentioned. There's also a splendid book called The Art of Agile Software Development by James Shaw. And also a book I recommend every programmer should read. In fact, I would almost say must read, and that's a Pragmatic Programmer book by Andrew Hunt and David Thomas. These are all, I think I'll call them classics in kind of agile thinking, and I recommend them to you. On page 66, you can find a summary of what we've been through. I would like to thank you very much for listening to this talk. And if you have any questions, please feel free to email me via the Lagos Agile and Craftsmanship meetup group, or send them on the group chat, and I will respond back to you. Thank you very much. I hope you've enjoyed listening to this. Thanks. Bye-bye.